Good afternoon, guys. My name is Dean Grantham. I'm from DEQ, or the Department of Environmental Quality. I'm actually a DIT member, but I kind of split my time, or I'm kind of duty stationed within DEQ. So Mike Griffin's in the same boat. I believe we had some other folks that are in the same boat this morning too. So it's kind of a different process for us as state employees. But at any rate, don't get hung up in the org chart. That's not what we're here to talk about. The next three sections, I think, we're going to try to take on a view of what DEQ is doing with geospatial technologies. One of the first things that we're going to talk about is David Peacock and myself are going to talk about a Division of Waste Management initiative with land use restrictions. So that's kind of a look backward, if you will. A lot of times land use restrictions are the end of these processes. So we get these facilities that come in, something happens, something is released. There's a land use restriction that's put there in order to maybe redevelop the land like brownfields would go through, or maybe just to capture what kind of constituent was released. But that's documented typically, and it's typically sent into a Register of Deeds office. It goes to a local government, so on and so forth. So we're going to talk a little bit about that. The middle presentation, which is Melanie and Carrie, they're going to talk about some things that we've worked with integrating different systems together. So being able to collect data via GIS, I believe I'm speaking of that correctly, and then taking that information and getting it massaged into a much larger data system, and the geoprocessing tricks and things like that we went to. So a lot of the things that you hear about with ArcGIS Server and geoprocessing and Power Automate, a lot of those kind of things are happening there. So that's kind of a present, if you will. So David and I were kind of the past to the present. They're kind of in the present. And then from the present to the future, Mike Griffin from the Division of Marine Fisheries, it just about escaped me at that point. It's getting late in the day. But at any rate, we're going to talk a little bit about our UAV program. So that's very exciting for us. The amount of data that we're able to capture with that, the orthomosaic, some of the products and videos are going to be shown. So a lot of good initiatives within DEQ. So we're trying to keep it in that kind of continuum, if you will. So David, I'll let you go ahead and get us kicked off, and I'll finish up and we'll go from there.
Thank you, Dean. So my name is David Peacock. I'm with the Division of Waste Management, Brownfields Redevelopment Section, formerly known as the Brownfields Program. So as Dean mentioned, I'm going to walk you through a little bit of our land use restriction database. So land use restriction data creation consolidation project. Well, I tried to find a really succinct way to put it, and this is the best I could come up with. GIS-based approach into tracking and managing institutional controls for better protection of communities while involving governmental transparency for current and future prospective landowners. So that's very compact, but there's a lot there behind the scenes. So, all right, where does land use restriction data come from? For the most part, it starts with the legislature. They create the laws, which therefore give power to the agencies to create these documents that get recorded, as Dean mentioned, at the Register of Deeds offices. These documents, as you can see, there's about 9 listed there on the screen. Very dry run when you read through them, but it gives that ability for the agencies to protect or notice properties so that when future owners go to buy them, they're aware of a possible impact. So one of the, I guess the number 7 on the list here, notice of residual petroleum, is probably, if anybody's done any research with environmental data, you'll probably hit or run into that particular notice. They're very ubiquitous. Okay, so moving on. Here's an example. These are what you're going to find at the Register of Deeds. This is a notice of brownfields property. Most of them are going to contain things like what you can do on the property and what you cannot do on the property. It could pertain to reporting or additional reporting based on the impact. So there may be a need for reporting in the event or maybe in the contingency that redevelopment is going to occur. So These present themselves as a way to notify the property owners and to protect them. Here's another one. This is the Declaration of Perpetual Land Use Restrictions. Now, this is by our Inactive Hazardous Sites branch. This is what they put on the property as far as restrictions. Here's a Notice of Residual Petroleum. Some of these text documents will also have a plat associated with it. So this is what the land use restriction data consists of. And of course, you've got, here's a local one. It's the Wake Forest Innovative Quarter, which isn't far from here, brownfields. Okay, so how do we get this party started? A lot of interagency collaboration. We came up with a team, basically a sub-team of our DWM GIS representation. So the smaller group is going to be representing each agency that collects or has this data set, a lot of which were in Consolidate or Access, Excel, maybe other derived data. So we were going to consolidate this into the GIS realm. We're going to agree to common attributes. That was one of the things that first we had to determine, what is this data going to consist of? We have book and page numbers. I mean, we have project IDs, these kinds of things. So we needed to figure out, well, what are we going to concentrate on? What's going to be the attributes? We also had to define and standardize our data input so we could be common across the whole section or the whole division, rather. And again, we had to decide how are we going to represent this data on a map. So this is where, in our case, first starting off, we basically only had point data, but there was an idea of heading into the Polygon realm. Okay. We also wanted to include web links. I think in our other session, there was a mention of the DWM site locator tool, which links you to documents online, Laserfish, embedded in Laserfish. And that was something we wanted to include in this project as well. And of course, public sharing. So, all right, and we needed to have a process for editing and maintaining that data set. All right, so we came up with the conceptual database design. We did come up with 26 attributes total across our section and programs that had the data set. It was going to be non-relational, so it was just going to be very simple, flat. And of course, I mentioned points. That was because access, generally you can only store latitude, longitude, at least in the cases that we were running into, Excel tables, so it was just easier to go with that. We also wanted to kind of keep with a set of chosen lists, so things like county. Obviously, we wouldn't have to enter in 5 different types of New Hanover County. It would just be one selection. So domain lists played a big part in kind of keeping it consistent. Web links, again, like I mentioned, to Laserfish, that was going to be managed as an attribute. So not coded in a pop-up or in another way to link to the information. We wanted it in the data set itself, so as an attribute. And then, of course, we were going to combine all of the information into one layer. So I will get into that in the next slide here. All right, so our first geodatabase. We utilized ArcMap and ArcCatalog 10.6. And we've come a long way, I guess, with ArcPro because I don't even hardly remember the ArcMap days. But using that file geodatabase with the domains, we would put on a shared drive, which if you were outside of Raleigh, it was very hard to access. You had to have special credentials to even log into that. But when you did, it was still kind of long waiting times to have that interaction with the data. So we ended up creating that, storing it on the shared drive so that every agency could have access. And then we created 8 or so feature classes that would be stored in that geodatabase one or each feature class representing the respective agencies. And then we combined all those into one feature set or feature class for publishing. And that's where ArcGIS came online. ArcGIS Online came into play. So that went a long way in updating and just having it available for another way to have it available for these agencies to connect to. So if you notice that our hosted feature layer and viewing was established in about 2017, so a few years back. And then once we had that out there, as I mentioned, the DWM site locator tool was available for viewing that data set as well. Okay, so the improvements obviously with us were moving into the ArcGIS Online and then using ArcGIS Pro. So the online publishing really lended itself for us to, again, access the data, be able to use ArcPro to go in, pull it down, put it on a local map of your own, and then do whatever feature editing you needed to do, attribute editing. We could do onesie twosie kind of things, as Dean likes to put it sometimes, or we could do bulk editing in general. But it's still limited in that we're only editing that one live layer, that hosted feature layer. So with that, this is what we ended up with. So as a map across the state, we divided it into properties that have notices or properties that have notices with restrictions, because there is a difference. For instance, solid waste, they will only have notices usually attached to a parcel, and it's just saying that, hey, there could be a former dump here or something like that. Whereas in a brownfields agreement or notice, it's going to have restrictions applied along with, here's the set of parcels that are represented as a brownfields. So what we ended up with is 318 notice properties and then about 6,901 notices with restrictions. And I think the bulk of those are UST or underground storage tank section. They record the notices of residual petroleum. So I think with that, I'll hand it over to you, Dean, and you can kind of jump on where we're going with it.
Yep. So as David said, we started this process with a file geodatabase, which is meant to be kind of a personal file. It's really good for one editor, but when you get much outside of one editor, then it kind of has its own limitations. And then we, from there, we divided it up, and then we put it into AGOL, and we started doing some editing in AGOL, but that still required somebody to aggregate all that information together, push it into one common, since it was a common format, but push it together into one layer and then share that layer back out for the public. So it was very time inefficient. So we knew that we had some room there to improve. So along in that time, we started to get more vested in enterprise GIS topics, or enterprise GIS technology, I guess you would say. So we built a SQL Server database structure, if you will, and then we hooked that to enterprise GIS, or we made that SQL database an enterprise geodatabase, if you will. So we could control the users, and that helped us out with having simultaneous editing. So we could have many different users connect to it and do editing all at that point. But then we also implemented ArcGIS Server, which allowed us to take that information, make REST services, if you will, register those in AGOL so that we could get that information to go out directly. So what that exposed to us was a good bit of technology, and that's really where we're going, where it's maybe not where we're going, it's where we sit today. But we've got to get that into production and get some advertisement about where this layer resides at. So I'm going to go through a couple of different slides there. Let me see if I got everything. The other thing that came up was that David mentioned that we had 7 or 8 different program areas within waste management. We're just one division. We're going to talk about 3 other divisions here, but we're one division with 8 different program areas. Well, of course, those 8 program areas didn't want to update on the same schedule. You know, one group wanted to do monthly, one group wanted to do quarterly, one group wanted to do annually. So we didn't want that to have to force when that data was published. We wanted those groups to be able to uniquely edit their data and make them as comfortable as possible in doing that process. So what we chose to implement was an idea of secured services. So those secured services that come through, again, our GI server that point back to the enterprise geodatabase, they're pointing back and capturing specific symbology. So when that editing group loads in that service, my screenshot there is a little bit hard to see, but when they load in that, they're getting a certain flavor of their features. Those features are actually filtered, so they're not seeing the entirety of all the land use restrictions, but just the ones for, say, the brownfields group or the inactive hazardous sites branch group. So they're just looking at those. So we were able to implement versioning on that. So each one of those becomes its own version. So we're capturing the deltas or the changes in those data sets, and then we can synchronize those back to that sort of maintenance schedule idea. We can synchronize those on our own schedule. So whatever that group needed is how we can synchronize those. They go up into essentially the master geodatabase and then back out to the public. So we're satisfying all of those different components. So we built a schema, we implemented that schema, we actually registered it so that we could get services out, and now we're to the point of actually putting this into practice. Oh, the other thing I didn't mention there was we had a situation that came up where we really needed polygon representations along this time. That became paramount. And if my division director or if the division director for waste management was here, he'd probably tell you a funny story about 2 neighbors, one that just purchased a piece of property and one that's meeting his neighbor for the first time. And their conversation goes, well, my name's John Q. Public, blah, blah, blah. Why did you buy land? Why did you buy a piece of property that had a landfill on it? The one that just bought the property said, well, I didn't know I just bought a piece of property that had a landfill on it. So where that comes from is that point, because again, we had this point geometry, and if you were dealing with a tract of land that was hundreds and hundreds of acres, that point only represented, it was an inventory point. It didn't actually represent, in some cases, where the actual waste was. It was just where, you know, it was an inventory. So by doing polygons, it gets us a little bit more resolute. It helps us to become, in effect, a lot more transparent, because then we can start tracking things by meets and bounds, by coordinate geometry, the same way that property mappers do, so that when you overlay our data on property maps, they should line up or come pretty close. So along with that, we've got different, with the enterprise strategy, if you will, we were able to do different workflows. So some groups needed to stay with points because that was all they could maintain. David mentioned our UST, or underground storage tanks group. They've got 6,000 some odd NERPs is what they call them, notice of residual petroleum. So, and they're all over the state, but typically they're tied to very small commercial properties, typically gas stations where tanks have been excavated. They found they had a release, they abandoned that in place, or risk base closed it, whatever. But at any rate, that's tracked via these documents. Well, we've got the other continuum, which is like brownfields or some of the other groups where they're very large areas. So we needed this dichotomy. We needed this different ways to edit. So the first way that I wanted to talk about was points. So for the UST group, they needed to be able to do batch uploads. So what that means is that they're taking data from another system, they're making XY points out of it, and then essentially replacing their information in the enterprise geodatabase. And then, as David said, my cliche, the onesies, twosies, you can go in and actually change those one at a time. So you can add 1 point here, 1 point there, take them away, so on and so forth. But again, it's all going into the same database structure. So there's no more sort of version conversion, that fear that we all have when people export a piece of data and start editing this, and then all of a sudden we've got two versions of the same thing, and then we have to merge those back together. This is staying in the same system, staying in the same canister. So for polygons, again, that new, if you will, workflow, we could edit through, or we found out that we could edit through ArcGIS Online. So if we needed to draw something in, the new map viewer that was just released has a really, really good snapping environment in it. I would encourage you to maybe take a look at that if you've not. It makes it very easy to snap to things, and like with the seamless partials layer, when we draw that into background, then we can snap to those partial boundaries. If we have a situation where we need to go a little bit further, we can always pull that secure service into ArcGIS Pro, and then we can expose all of the editing tools there. So the coordinate geometry, the traversing, all of those different things are at our disposal. But again, the really nice thing is that all of that work, all of the editing goes into the same canister, so we can make it actionable to the public very easy. So again, I kind of got a little bit ahead of myself, but we can push that information out to this public layer, and then we can expose that through ArcGIS Online or through our open data portal, and folks can bring that into whatever kind of mapping application they need. And then we've embedded these Laserfish links. So I'm a huge, huge advocate of Laserfish because in terms of document management, within the context of the Division of Waste Management, it's probably our largest single repository of data, because within Laserfish, we're tracking monitoring reports, we're tracking plats, we're tracking legal documents like this that go to Register of Deeds office. There's a myriad of different things that are there. So if we can give somebody a GIS tool that allows them, that gives them, dare I say it, that Google Maps experience, but they can just bring that up and we don't have to train them. They just click on a point and they say, oh, well, if I need to go to the plat, I can go here. Oh, well, if I need to go to the legal document, I can go here. That's what we've implemented. And a couple of different flavors there you can see from the pop-up. It gets you out to Laserfish. It works really, really well. So again, just to give you a link there, our open data portal or our open data page, you can go there and search for LUR. In the near future, in the next few weeks, we'll have that up and running, I think, once we get it moved into our production environment. We're sitting in test right now. But at any rate, so we're pretty quickly approaching that. And then that brings me to the end. Got about 5 minutes left for the first half hour. Any questions for me or David about anything we did here? Sure.
Yeah, so how does the team work, I guess, in this instance, with incorporating the pipeline that you have for that? Some can say, inspector goes out in the field, they want to make an inspection, and they go from that point and catch to that point as well as going with
It's possible, and it's very much in our future, I think. We need to have a much finer grasp on linking or integrating different technologies together. But in what you just said, you know, you've got an inspector that's doing an inspection that generates some kind of report, something like that, that needs to go to Laserfish, but it also needs to be accessible from GIS. I think all of that is possible. We're not quite there yet as an agency, but I think we're building the platforms to do that. This is one. This is an exercise of one. We have some other things that are in the mix there too, but you had mentioned like, or I'm thinking of like the Power Platform for Microsoft, or Power Automate, those kinds of things that could automate some of those processes and get us a lot further down the road, but it's definitely in our future. So, any other questions? Okay. So we're about 4 o'clock, right? So I think our next presentation is going to be from Melanie and Carrie. I'm not sure which one's speaking first, but I should have asked that question prior to this, but I did not. Dropped the ball. They're not going to ask me back. So that's it. Thank you.
All right. My name is Melanie Williams. I am, of course, with DEQ and Division of Water Resources. And today we are going to tell you guys about a tool that we have just kind of launched publicly. It is the sanitary sewer overflow reporting tool that we have just launched, I believe it's back in October. This tool started with one question. Can you map all the SSOs that have occurred in the past 6 months? It was a really simple answer. No, we can't do that. That's not an acceptable answer. Of course, we're GIS people, let's figure out how to do that. So we kind of started digging into how do we accomplish something like this. First, we need to know where does the data live. We need to know where the SSOs are in terms of where that data is being housed. So in DWR, we have a permit database that we so lovingly call Bims. And it is probably one of DEQ's oldest databases, possibly. And it is a bear to get anything out of that database. So this was a fun adventure. So first we started looking at where is the location data housed within this Bims database. So, spacebar. Awesome. Okay, so this is kind of an example of if we wanted to output all of the SSOs out of our Bims database to just kind of take a look as to what data is there, what data they collect, and what data they report out. This is kind of what we get. And you can see in that last column there, this is our location data. This is what's being stored. Pump number 5. No idea where pump number 5 is. There's no system, there's no standard way that our staff has ever needed to record location information for SSOs. Our SSOs are reported from utilities to our regional office staff members. And those regional office staff members know exactly where all of these locations are. And no one ever told them that we might want to stick this on a map one day, so give us like some kind of address or something. So this is kind of what we had to deal with, what we had. So this wasn't just a, well, let's extract the data and figure out how to map it. We stepped back and realized we kind of really actually need to adjust this entire workflow. Because if we want to be able to map these into the future, we're going to need that point on a map. We're going to need an address, a lat long something. So we started looking at, all right, well, how can we get our regional office staff to report lat longs into Bims? Turns out, since it's a very, very old system, we can't just add fields in the system. So we needed to look for a different way to do this, just all together. So what we did is we decided, well, instead of trying to force Bims to change, which was really, really difficult, instead, why don't we try to collect the data through Survey 123? We can pull in all of the corresponding data sets that we need, all that relational data that our staff needs to be able to have their domain lists and what have you for when they fill the form out. But it also gave us that mechanism for them to be able to pull up a map, drop a pen, and that's all they had to do. They could also then be able to fill this out in the field, which turns out that was a huge time saver for them. So what was happening before was they would get a call, they're in their car, they would have to pull over, they would have to write all of the information down on a random piece of paper and hope that they remembered to gather all the information they needed. Then when they got back to the office, then they could enter the data into Bims on their computer. So now they can take their tablets in the car with them, they pull over and they can just log it directly into the system. Stores it into Survey 123. And we have all of the data that we need. We know that we have all those fields filled out. So it definitely helped us with some of that data accuracy issues as well. So then how do we get that data out of Survey 123 and into Bims. This was one of our sticking points. We've always been able to get data kind of out of Bims, but never really been able to push it into it. So we started looking around for different tools. We had data interoperability as a tool that was available to us, but we had never used it before. So we started doing some research into that, and I'm going to let Carrie talk more about that in a second as she figured out that process of how to get that data through data interoperability, Power Automate, and into Bims. And it was kind of an awesome process. So once that data goes in there, then we were able to put it into a live online map so that the public could actually see where these SSOs were on the map. Not only that, they were able to see the amount, the size that was spilled onto the ground and that may have reached waters of the state. A lot of these waters are also recreational waters. So if you want to go kayaking, it'd be nice to know if there was a sanitary sewer overflow that had reached your water recently. So this helps the public gain that insight as to a little bit more insight into the water quality of the streams that they're about to go play in. So it also provides us a mechanism to have additional information as the utilities come back. They fill out a 5-day report with a lot more accuracy, and people can start to see where some of these SSOs are clustering around the state. So it just provides a lot better insight. The Survey 123 tool provided a fantastic way for us to be able to get much more accurate data into Bims that we can then report out to the public. So I'm going to pass it over to Carrie, and she's going to talk about how we were able to get all of that worked out through data interoperability.
Thank you, Melanie. Hi, everybody. I'm Carrie Hanko. I'm a GIS analyst. I work with Melanie at the Division of Water Resources. So like she said, it was a real mystery on how to move data back and forth between this legacy database. We discovered the data interoperability tool, which is a part of Esri's ArcGIS Pro. It is a paid service, so it requires Esri's data interoperability license to use. It's created by SafeSoft, where they call it FME on their end. So basically you can interchange the name data interoperability and FME. They're basically the same thing. But as you can see on this display, this is kind of where you would access it if you have data interoperability. Go to your toolboxes and select a new Spatial ETL tool. And so essentially it'll be creating a new tool for you in that toolbox. So like I said, some of the challenges of using data interop is that because it's created by Safe Software or FME, most of the training for it is directly through FME, Safe Software. But the good news is that they had a lot of wonderful training available for free for people to view. Another challenge was that you needed to have your versioning correct. So whatever version of ArcGIS Pro you're using, it had to match with your data interoperability. Same goes with the version that goes on to ArcGIS Enterprise. So you have to make sure that your versions match in order to work successfully with it. I was really surprised at the amount of very useful documentation that is built into data interoperability. So every tool that you use, every transformation that you use, they have a nice little help button attached to it, which takes you to the page that explains what this tool does. And you can easily get to user questions as well. People who have had basically looking at solutions to some of their issues as well. So it's really, really useful amount of documentation out there for it. And it's kind of similar to a model builder in its use, but it has over 450 different data transformation options that are very much no code or very low coding. But for those coders out there, you can actually also create Python code within it as well. So when we were figuring out how to interact with the Bims database, we were kind of looking at two routes. The first route is moving data from Survey 123, which is housed in AGOL, and moving that to Bims itself. But then we're also going to need to take that data back out of Bims and keep our AGOL feature service up to date. So we kind of went through the steps of what that would look like. And for us, the first step for getting the AGOL data into Bims was to look at the Survey 123 data and read that data into data interoperability. And then the big one was formatting the data attributes, because the Bims database is an overly normalized database. It has a lot of rules associated with it. It has a lot of format-specific rules that we had to stick to. And then from there, we discovered that we could take this data from AGOL and turn it into an XML file. And that XML file could be sent via FTP, very old school, to the server where Bims could pick it up. And our wonderful Bims IT staff worked on their end to be able to translate that into what Bims could read. So looking at the return of data back into AGOL, it's kind of a very similar process, but in reverse. So we start with a live look at the Bims data through a web service. In this case, it's a JSON. And data interoperability can grab that JSON data, convert it, and match the attributes to what we have in AGOL, and pull that data back into AGOL once Bims is done with it. So this is kind of a look at what the Spatial ETL data interoperability tool looks like. You can see there's a whole, it's probably hard to read for you people in the back, but there's several different steps that we're going through to pull this data out of AGOL, transform it, put date stamps on it, split out the attributes, rename attributes, make sure that what data that Bims has matches the data that we have in AGOL, aggregate it all together as an XML file, and then FTP send it out to Bims. And we have this method running daily at 8, 10, noon, 2 p.m., 4 p.m., and 6 p.m. every day. It's running and putting that data into Bims. Now, we looked into doing it a little bit more frequently than this, but it turns out that this is about what Bims can handle. So when we're pulling data back out of Bims, it's kind of working in tangent with what's going on when we push the data into Bims. When we pull it back out, we're staggering this run about 30 minutes later. So Bims takes about 30 minutes to do its thing, process the data. But we need some information out of Bims to put back into AGOL. And in this case, it's an incident number. So every SSO that occurs gets an incident number from Bims once that incident is placed into Bims. So we need to get that information back out of Bims. So we're actually running two different feeds in this one tool, and they kind of connect together. You can just kind of follow those arrows around. And first we're pulling in that JSON that we're getting from a data service, and then exposing those attributes, and then we're testing them. We're seeing, okay, which ones already have a Bims ID in there? And we're filtering out the ones that don't have that ID. So the ones that don't have an ID are now going to be merged or joined with the feature service or the JSON data that Bims is sending to us. So once we have that join, we can pull that incident number back into AGOL for us and kind of complete that cycle. The lower part of this flow that you're looking at is, so the first thing we're looking at is 24-hour data. However, each of these utilities will go in 5 days later and create a final report. So they're updating their data in this final report. And so this bottom section is looking at the data that is from the 5-day report and adding that back into the AGOL feature that didn't originally have any of that data in there. And like I said, this runs the same kind of schedule as pushing the data to Bims, but this one is staggered by 30 minutes. So when we were originally putting this together and testing things out, we were wondering how we can go about automating this task. Originally, we were looking into using Windows Task Scheduler because we had it locally running on our computer in the Archdale building in Raleigh. And it's a shared computer that Melanie and I could both work on. It worked okay, but we were looking for a better method, a more stable method to run this. And then along comes Hurricane Ian. And when Hurricane Ian occurred, in a very crucial time for us to get this SSO data, unfortunately, the power and the internet both went out at the Archdale building and in our backup location. And so when we needed the data the most, we did not have it. At that time, we were testing putting it on enterprise server, which would be much more stable. And we had been running it as a test. We had just started doing that. It wasn't in production yet. Well, while this occurred, the version that was running on test and enterprise server worked perfectly. But unfortunately, at that time, it was not what was live. So that really sealed the deal that a big tool like this is best kept on enterprise server. So we went ahead and loaded it onto enterprise server. And basically, you're throwing this as a tool into a model builder and putting it on enterprise server. And then from there, you can automate it using Power Automate. So this is kind of what the flow looks like for automating it on Power Automate. And in this case, we're housing the tool on enterprise server in a secure folder because we don't want just anyone to be able to access it. So we have a child flow in there, which is creating a token that gives us that authentication token that can use to run this tool on a HTTP web post. So we have an HTTP post. It's bringing JSON posts saying, okay, run this tool for us. And we have it scheduled at the same schedule I showed you in the previous slides. And it's gonna run this on that schedule. And we also have a methodology of appending to a file on SharePoint information about the run in case we need to go back and look for any errors. Okay, back to Melanie.
All right, so what all of that allowed us to do was really be able to flow data in and out of Bims, which was basically unheard of, we thought. Data interoperability really opened that door for us. We knew it was a tool that we had out there in the distance. We've looked into it a couple times. We tried to get some Esri training. There wasn't a ton out there. Once we found the FME training on their website, it just opened so many doors. So if this is a tool that you guys are interested in getting started with, if it's an ETL tool that you've been thinking about jumping into, I highly recommend go out, find their help page. They have tons of tutorials on there. They have great videos to help you through that. And it's a really fantastic tool that's helped us be able to bridge our different platforms. will now be able to take this, what we've developed here, and be able to open the door for the rest of the data that we store in Bims. It's always been somewhat of a locked box, but now we'll really be able to reach in and be able to interact with that data a lot better. So with that, that's kind of DEQ's present. And I'm going to turn it over to Mike Griffin. Oh, right. Do you have any questions? Yeah.
So I work for a water and wastewater utility. I'm familiar with how we internally report SSOs.
Yeah.
I'm less familiar with how it ultimately ends up in Bims. But my question is, do you plan to extend this survey 123 tool directly to utilities to decrease that reporting time and transparency? I suspect you're limited by the incident number being generated within Bims.
It's a great question because that's exactly where I would love to go. There is a little bit of a mindset change within our division itself, right? Like this was, for decades, this is how it's always been done. And so with this kind of complete change in workflow for our staff, it's one of those, let's kind of baby step it a little bit. So first, let's test this out. Let's make sure this workflow is really solid. There's not, big things that kind of pop up here and there. So far, it's gone pretty well. I'm gonna knock on some wood. But eventually, what we would like to do is open that up so that the utilities can report directly. So what we have now is whenever a survey is submitted, we use Power Automate to send an email not only to the staff that entered it, but other staff in the region so that they know that that SSO occurred in case someone needs to go out and investigate. So that email will, if we were able to get the utilities to enter that data in directly, that email will still kick off. So our staff will still know. It's not something they're quite ready to let go of yet, but I believe within the next couple of years, that's where we're headed. Yeah. Any other questions? All right, so.
Way back there.
Oh, yes, hi.
Has there been any consideration for when you have an SSO that's entered into your survey 123 that'll work with the water utility, if that email chain, so that they can determine the cutoff at the end of the day, so they can plan accordingly?
Yeah, that's also an awesome question. So the question was whether or not there is something within the system that also alerts the water utilities to possibly shut off intakes if they need to, if that SSO is headed down their way. So as of right now, we don't. But what we do have is we now have this SSO data set that we can put into our public water supply spill response application. So then our regional office staff on our public water supply side then will be alerted and they will know that those SSOs have occurred. They can start to map out the area of impact for them and let people, the utilities know that there might be something headed their way. But that's a great idea of something to possibly go towards in the future. Thanks. Anything else? All right. Now I'm going to turn over to Mike Griffin to talk about DEQ's future.
All right, thank you. A couple of great presentations there. Good work going on. No pressure here. Make me go last. So I'm going to be a little bit dependent on the Wi-Fi here, so bear with me. Hopefully get some good bandwidth. Got a lot of different things to show media-wise and some different softwares that we're using. So I'm going to try to step through that. Talk a little bit about our drone program, how we got started, how we developed a policy, some of the work we're doing throughout the state. We, Murphy to Manio, pretty much, we're flying drones. So it's come a long way in a short time. So just going to go through the process. This is a cool little image here from Cape Lookout. We just did some habitat mapping there, so we got some aerials while we were out there. So this whole process started in 2018. Our CIO for DEQ, I approached him one day, his name is Mike Ware. Some of you may know him, but I said, Mike, we need some drones here at Fisheries. So he said, well, get me some ammunition. And, he wanted us to go out there and get some, case studies, something that he can take to DEQ and say, hey, this is a really good idea. We need to get some of these drones and get a program started. So we started that process in 2018 with kind of a joint collaboration with UNCW. They had a visiting researcher named Kenji Sakamoto who was from Japan. And he was doing quite a bit of SAV mapping with Phantom 4 units. So we hooked up with him and, said we need to do a case study for fisheries and we want to look at our habitat mapping program. So we identified some study areas in the Fort Fisher area at that state park there. And since it was a state park, we had to get approval to fly in that state park. And we found that, we can fly an 80 to 100 acre grid in about 15 minutes with that Phantom 4 with ridiculous resolution. Like you can see a blade of grass, you can see an oyster. It's truly astonishing, like the level of detail you can get. Just with, Phantom is not a extremely expensive drone. At the time they were about $1,500. But the resolution you can get with these is, truly, it's amazing. So we did this with the Phantom 4, looking at the habitat mapping. And traditionally, with habitat mapping, this was done with a 3-person crew. So if you're mapping and all the mappers are in Morehead City. So if you're mapping in close to South Carolina or up in the Albemarle or, somewhere away from Morehead, you had to have 3 people tow a boat at, sometimes 2.5 hours away from Morehead City. You had 1 person driving the boat, 1 person polling, and 1 person identifying strata. So that person could draw that on the map of the different habitat types. With that method, you get about 10 acres a day. We found with this case study, we could map 600 acres in one 2-hour stretch around low tide. So we want to fly everything within an hour before or hour after low tide so we can see that exposed habitat, the exposed oyster rocks, exposed SAV, things of that nature. So you're going from 10 acres in a day, traditional methods, to 600 acres in a 2-hour window. So, a lot of efficiencies found there. So with that, we found that over the case studies that we completed with UNCW, our efficiency increased 5,900%, which sounds outrageous. But when you take into account how they did this in the past, it's amazing. So we took this to Mike, and Mike said, okay, now we need a policy. So we started developing a policy, and I know you probably can't read this policy. I just wanted to give you like a little snippet to see, it's 3 pages. We've got links in here. But I'm going to make this story map public. So if we get questions about this a lot from other states, establishing programs. If you're curious of what we put in our policy, you will be able to link to it from this story map. And we will put this on the open data page that was mentioned earlier in the presentations. But when we started this policy process, we coordinated with established programs. So we met with the Duke Marine Lab, which has a pretty significant drone program. We met with the NCDOT drone program. So you need a FAA license to fly commercially or in a government entity, but you also, in North Carolina, which a lot of folks don't need this, you need an NCDOT government operator permit. So we met with DOT, and they had a drone program, so we kind of bounced ideas off of them with their policies. And it was a collaborative effort between NCDIT and NCDEQ to get this published. So we got 2 or 3 drafts done amongst ourselves, and then we sent that to the DEQ lawyers. And the DEQ lawyers butchered it and added a bunch of statutes. So they made it stronger. So the big sticking point for the DEQ law office was the private property. So, when we met with the Duke folks and, even, some of the UNCW folks, they've got a little more leniency in their policies with private property. But being DEQ is a regulatory agency and a state agency, we're open to more scrutiny. So our first policy said absolutely no flights over private property. So we operated that way for the first year of the program. After the first year, we revisited that because one of the programs, actually a couple of our divisions do inspection type work with these drones. And a lot of the inspections that they're doing are on private property, whether it be dams or landfills or things of that nature. So we amended that policy after the first year of operation and added the capability to fly over private property, but you have to get written authority to do so, which was not a big problem for those inspection type works because they already had to, those private entities already had to sign contracts with the state for inspections, like normal inspections. So we just added the, actual aerial aspect to those authorizations. So, like I said, we started it was like April or May of 2018 with the project, with UNCW, and then started formulating the policy. And long process, we finally got approval in January of 2019. So that's when our DEQ drone program actually officially started. So once it did start, we had rapid growth as far as a lot of drones coming on board and a lot of pilots. We've got 30 active drones in the program now with over 45 pilots across the state. And with that, we needed to have a mechanism to manage both the aircraft, and each aircraft has multiple batteries, and pilots as well, because you've got pilots that got certified at different times, so they're up for renewals at different times. So we needed some mechanism to keep track of all that. So we started with a Kitty Hawk system, which later changed their name to Aloft, and that was just a fleet management software, which does all that for you. Keep track of your pilots, drones, everything, any kind of maintenance, and that worked well for us. I think we had it for 2 years. But then the Esri product matured. So Esri now has a site scan product, which is very similar, but with more bells and whistles, and it integrates seamlessly with our other Esri products. So with ArcGIS Pro, with Drone to Map, you can push orthos directly from site scan to ArcGIS Online for scenes and things like that. So it's pretty slick. I'll show you a little bit about that real quick. Here's where we need that Wi-Fi. Looking good so far. So when you come in here, you've got a cool little dashboard. It pops up, as the last 3 months, you can see we've got, 5 hours of flight time, 59 flights, 8 pilots have flown in the last 3 months. It shows, the different flights on the right-hand side here. And it's kind of cool, the heat map here. So you can see where the concentration of flights are being carried out within DEQ. And you can also come up here and change, your go to all time or, last month. We've done 2 hours, 14 flights in the last month. But you can click on any of these. Looks like somebody has flown today. See if they process any data. Yep. So the other cool thing about SiteScan, when you fly, you can upload, if you have an internet connection, you can upload from your tablet and to the cloud, to SiteScan, and it'll process that data for you. So we use Drone to Map quite a bit, and with that, you would have to take the SD card out of your drone, come back to the office, download your photos, bring it over to Drone to Map. Drone to Map will process your data locally. With this, you don't have to, you need a fairly decent computer to do that, and whenever you're processing those orthos, you can't do a whole lot else on that computer. Definitely not any GIS work because it's just taking up so much of the resources of that machine. So that's the really cool thing about SiteScan. You can upload that data, all those pictures, to the cloud, to the Esri cloud, They will process the data for you and then send you an email when it's done. And you can go log back into SiteScan. You can view it here. So we can, turn off the ortho, see what just a typical imagery looks like versus what you get with the drone. Typically with your Google Earth type imagery or your regular Esri imagery, it gets blurry as you zoom in. That's your typical versus what you're getting with the orthos from the drones. So it's pretty cool. And when you're in here, you've got this little cloud at the bottom. So if I click there, I can log into my AGOL account and I can push this ortho directly to AGOL and put it in any application you would like in AGOL. You can also pull this into Arc Pro and run any type of analysis you would like. Like I said, it's very seamless and repeatable. So, they flew this area today, which I don't know why this is headquarters in Moorhead. They may have just been practicing something today. But say we've done this quite a bit for, for hurricanes coming in. We'll do an ortho like this pre and post. So if there is any damage, we can document that for any insurance claims or things of that nature. But we mostly do habitat type work at fisheries. So we're more in the water and the marshes, SAB, oysters, that type of work, which I'll show you that more here in a second. So like I said, now we have 30 drones in operation. Our current fleet is 2 of the Matrice 300 RTKs. That's a larger unit. It's probably about as big around as this table with the props. And the cool thing about that is it's got the hot swappable sensors. So, you can have your traditional RGB in there, or say you need multispectral, you can pop out the RGB, put a multispectral in there. Or if you get into LiDAR type work, which we want to do for the western part of the state with the landslide mapping and things like that, it's very easy to just, plug and play with those sensors. So we've got 2 of those now. We've got 2 of the Phantom 4 multi-specs. And with that, you get the red edge, engineer it for red, green, 1 dedicated RGB, and then a red and blue. Phantom 4 RTK, so that just gives you that really precise positioning, which the RTK is available on the Matrice and the Phantom 4 multi-spec as well. Anify work, this is a great drone for inspection type work. A lot of your drones have a limited sensor range, so you can go, looking directly out, or you can go what they call nadir, which is 90 degrees down, or anywhere in between. So the Anify is kind of cool because you can fly under bridges and point that camera up. So if you want to, say you're DOT and you want to look under a bridge and do inspections, you can do that with the Anify work very easily. The Mavic 2 Pro was our kind of initial splurge and has been kind of the workhorse of the program so far. A lot of the images that you will see here was done with that Mavic 2 Pro. And we have 15 of those. We've got a Mavic 2 Zoom. So the Mavic 2 Pro has a 1-inch Hasselblad sensor, which is really good for mapping. It does have a electronic shutter, which is not as great as a mechanical shutter, but just means you need to fly a little slower. Mavic 2 Zoom is good for like Marine Patrol if they need actually to get up on somebody or look at a boat number without having to get that drone close to them. They can use the optical zoom on the actual camera to zoom in on those type features. And then we have another Mavic 2 Pro with a Centera multi-spec sensor. So that's the same as the Mavic 2 Pro here, and we kept the Hasselblad camera on that, but it has another multi-spec that goes over the top. So you can get the multi-spec imagery as well as the traditional RGB with that Hasselblad camera. All right, and I just want to show you a few examples of how we're using, I might already have one up. How we're using it across the state. So the first one here, this was taken at Southport Marina after a hurricane. I always say this wrong, Isaias or is Isaias? Yeah. Hurricane I. this was back in August of 2020. And so you can see the marina here. There's supposed to be docks everywhere with boats filling up all this area. You can see where all the boats are pushed up next to the dry stack storage. The docks are gone. You've got boats in the marsh over here. So Marine Patrol took these images, and they have some videos of this as well. So Marine Patrol is, responsible for, after a hurricane event, they go out with drones and, at the time, collector, now field maps, and they mark where all these stranded vessels are. So we know where we need to clean up the waterways. So that's an example of the hurricane response. Let's go west. This is an example of DEMWare using it for landslide mapping. And I'll show you a little bit more about that in a second. Also, DEMWare using it for sinkhole analysis. This is the habitat mapping, just an example of one of those images that we use for habitat mapping. We caught a little pelican here. But you can see the oysters in there. And, the software we have, we've got some machine learning that can, with the orthos, that can auto-identify strata. And, we have to do very little cleanup, as far as adjusting things here and there. But we do have to tune that essentially for each area, because there is so much difference in the, spectral range when you go from one area to another. So there is some tuning to that, but it's still much quicker than the traditional method. Here's another example of that, one of those habitat mapping images. This is an example of a shellfish lease. This is a water column lease. The rows here have essentially bags filled with oysters, and the oystermen go out there every now and then and flip the bags. But Fisheries is in charge of inspecting these leases on an annual basis as well. And see how well our Wi-Fi works here. So another thing that Fisheries does is we build estuarine and offshore artificial reefs for recreational fishermen to go out and enjoy. And this is an example of that. We were sinking an old Coast Guard ship, which was renamed the Brian Davis after a diver that passed away while he was diving, but his family paid for the ship to be sunk on an artificial reef, kind of in remembrance of him. But we documented this with the drone, and we'll see if it will play. It's just a quick little shot. But it was a 180-foot vessel, and you can see it's kind of going down pretty quick here. What you don't see is we were out there 10 miles offshore for about 5 hours waiting for the crews to cut enough holes in this thing to get it sunk. So the actual sinking, once it started going down, was like I said, about a minute. But it was pretty cool to see once it finally did get sunk. And so a couple of the Parker boats here, that's these here with the covers. So looks like another one there. So those are Fisheries boats, and on those boats we have side scan sonar. So as soon as this boat was sunk and the Coast Guard said, okay, we're settled, like, the boat's still not shifting on the bottom, we sent the side scan sonar boats out, and they mapped the whole area with side scan sonar. And that's available in our artificial reef guide, which is also an AGOL, that you can go out to these fishing sites and you can see on your phone, okay, I'm above this ship, so you know actually where to throw your line to fish on these different type bottoms. So that's kind of cool. So that was a few of the examples, and I said I was going to get back to the debris flows. So this is a scene. Like I said, you can process the 2D and 3D models within SiteScan. It does everything for you. It sends you an email when it's done. Once it's done, you can take it, send it to AGOL. This is what we did here. And this is an example of a scene, 3D scene in AGOL. This was done with one of the Mavic 2 Pros. But the cool thing about this, this is just kind of a scene for viewing, but we can also bring this directly into ArcGIS Pro, and there's all kinds of analysis we can do in Pro. You know, essentially with the click of a button, you can trace an area, so you can see that it's all cleaned up here. But when you have these debris flows, a lot of times it blocks the road. So if it was still blocked here, you could essentially draw a polygon in Pro around that road, and it would give you the cut and fill, essentially the volume of material you have covering that road. So that allows us to relay to, DOT, you need this many trucks because you have this much material blocking that road. So it helps a lot with the cleanup effort of that. And the survey, you can do a survey of it in 15 minutes. Depending on how many pictures, you're probably looking at an hour to, 3 or 4 for a site scan to process the data and send you an email and say, hey, you're good to go. So it's fairly quick. All right, and we'll go to another story within a story. So kind of the program that got us started, that initial case study, was the benthic habitat mapping program. This is where we did that Cape Fear study, and this is an example of one of those areas, Hoop Pole Creek, which is located on Pine Knoll Shores, directly across from Morehead City, near where the Pine Knoll Shores Aquarium is. So this is an example of what the different strata look like. These are all the different stratas that we map in that program. They look at, where the oyster rocks are, where's the SAV, what's sandy bottom, what's muddy bottom, what's marsh, that kind of thing. So, like I said, we've come a long way. This is an example of how this program used to operate. You can see this is a paper map. So the person driving the boat was also responsible for drawing on this map where the different stratas are. You can see why we did 10 acres a day. So what GIS would do, they would print these blank maps with just kind of a general shoreline on it, give it to them. They'd go out in the field, complete an area, and bring it back to GIS. We had to scan it, georeference it, and then draw in, make the polygons based on the lines that they drew on the map. So a long, tedious process. From there, we went to drones. Like I said, we increased the areas mapped in a day by 5,900%, which is pretty outrageous when you think about it. 10 acres to 600 in a day. It's a pretty cool feat. But this is the area there in Hoop Pole Creek that we did for this study. And just an example of how you can zoom in. You can see these oyster rocks here. This is an example of our flight line. And everywhere you see a yellow dot is where the drone took an image. And then the finished product. After we get it back, after that, have that ortho mosaic, then we can draw in the strata and see where the rocks are, where the SAB is. And this is just talking for that one area that we were looking at around Cape Fear. That's a 7,500 acre area. With the traditional methods, it would have been 750 days to complete that area. With the drone method, it would have been 12.5 days. And it was estimated that we saved on that project alone $400,000. When you talk the manpower, so you have 3 staff going out in the field every day. You've got to drive from Morehead, towing a boat. You've got to pay the gas for the vehicle, for the boat, for 750 days. So amazing savings there. So we definitely got Mike his ammo to sell it to DEQ. So that's kind of the nuts and bolts of where we've come with the drone program, kind of a few of the examples of how we're using it. Now we've got, Daimler, water resources, waste management, fisheries, no air quality yet.
Not yet.
but quite a bit of fisheries of DEQ is using these drones now. Like I said, 45 pilots across the state in various divisions. So it is growing rapidly, and we recently purchased 9 new drones with new capabilities. So we're, excited about, what we can do with those new sensors and new payload capacities. With the matrice, we can carry a lot more weight. So we're looking more into water sampling from drones. We did a little bit of that with the Mavic 2 Pro, but we only had like a 2.2 pound limit on that. So we couldn't do too much. 2.2 was pushing it, especially if you had any wind, which we typically do on the coast. So we're excited about that matrice and being able to explore the water sampling aspect more. So any questions? No news is good news?
I guess that's it.
All right.
So in closing, as representative of DEQ, you can see that we're doing a lot, as far as using software that we've got with the drone program, just making kind of use of existing resources, but then also moving forward. And I think that that's a key that I've heard in a couple of different presentations here today. What we're really trying to do is to become more efficient, but we're also trying to lay a foundation that allows us to be more of it builds kind of a decision-making tool or a presence, if you will, so that we can go further. We can do better things. We can make better decisions down the road. So that's kind of where we're at. So when we were asked to do this, I said, we have an internal team that's called the Geo team, where we all get together and we talk about everything we've done every quarter or whatever. But I said, sure, we would like to get in there and expose some of the different technologies we've got. And I don't know, it's been exciting for me as somebody that's implemented GIS in the past to come into an agency and then see this growth happen, because it's really happened fast. That was not something that we necessarily talked about in our timelines, but I know David and I, in our presentation, we talked about, I believe the earliest date was like 2018. Is that right, when we started? 2016. So that was pretty recent. Melanie and Carrie's was in the last year, and then Mike, we're still kind of ongoing, but when did we start the drone program? What was the date?
Officially started January 2019.
2019. So, so all these things have happened in just a few years. So where we're going to be in just a few years more, I don't know, but it's pretty bright for us. So, but at any rate, I appreciate your time, your patience. If there's one last call for questions, I believe we got just a little bit of time, but nobody had any. So thank you, guys.